Yes, this class is a continuation class on first principle. And please, if you can recall, I said that polynomials are mostly being solved by first principle. So anything that has to do with letter and their power, we use first principle for them. So this video is a continuation on this, continuation on first principle. The set of questions I'm going to be taking here is going to be different from the first video. This one is more advanced because they actually require some special attention that is different from the one I did earlier. All right. So let's take question 1. What if you are given something like this? If y equals to root s, they now said find the derivatives. Yes, don't get it wrong. It is still the same thing like find dy ds, and it's still the same thing like find y prime, just like in the other video. So you can either be asked to find the derivative, or find dy dx, or find y prime. All right. So now let's solve this. So the question is, if y equals to root x, find the derivatives. Very simple. Now, the first thing you are going to do when you come to this place is to express this root x in an index form. Whenever we say index, index means power. So anytime you see a root, the index form of a root is power of half. There's a law of indices. If you are very, very conversant with your law of indices, you should be able to know that there's a law that says whenever you have a power of, you have a fractional power, you are going to let the denominator become the root while you leave the numerator. So this is what gives what you have here. So in similar manner, you can always interpret anytime you see a root, you can change that root to become power of half. So it means square root is actually also the same thing as power of half. So the first thing we are going to do is to interpret this format to look like this. Then you will now continue using your first principle. According to our first principle, this is our power. So you are going to bring your power to the coefficient side. That will be 1 over 2x. And you know you must minus 1. You must minus 1. Yes, it's very, very important. So you are going to get the power and subtract 1. So the power will first come down, then you subtract 1 from the power. All right. So when you do that, 1 over 2 is still here, and x is here. So you can just go somewhere quickly, or maybe at the back of your note. Then you now quickly find the LCM of this. What you need to do here is LCM. I want to get a particular answer for what I'm having up here. So you can put 1 here by yourself so that it can look alike. Then find the LCM. The LCM of this denominator is 2 times 1, 2. So you will now say, how many 2 can you see in 2? 1. 1 times 1, 1 minus. How many 1 can you see in 2? 2. 2 times 1, 2. By the time you subtract 2 from 1, you are going to have minus 1. Minus 1 over 2. So that means when you express what you have here, you are going to have negative half. Negative half. So that is exactly what you are going to get when you do the LCM. Alright? So don't always let this thing be involved in your work. This is a rough work. Go and do it somewhere and just copy the answer so that you can move on. Alright? So that you can move on. That will be what? Minus half. Alright? So when you get to this stage, just continue. Now you now have to use your knowledge of indices. Whenever you have a minus as a power, that minus means 1 over 1 bar. So for you to express it, it's going to now be 1 over 2 multiplied by 1 all over x raised power of half. So what bring this bar 1 into this our expression is because of the minus. Whenever you see a minus on a power, that minus is 1 over, that's bar 1. Then whatsoever thing you have with that minus, bring it down. So from this, our structure now become 1 times 1, 1 all over 2 multiplied by x raised power half. That will be 2x raised to power of half. Now you now return this thing back to where it's coming from. So you know that anytime you see power raised to power of x raised to power of half, it means that what the denominator will become the root. So it will now be what 2 root x. So you know that this thing is square root. So the original shape that we have here is root is majorly for square root before we have other roots. All right. So for you to write the answer, just write square root of x. You can put 2 here if you like, but if you don't put 2 here, everyone knows that this particular symbol, this shape means square root. Right. So the 1 is still there, but when something is carrying 1, it's useless. So it's very simple. Whenever you have a fractional power, the denominator becomes the root, while the numerator remain where it is. So what root this x is this 2. And since this symbol is already square root, so it's allowed that you leave the answer like this. And that is your final answer. You see? That is your final answer. Very, very simple. All right? You can pause the video and try to practice it. Yes. All right. What of this? What of if you have this? This one is more advanced than the one we just finished. This is example 2 under the continuation class. All right. So very, very simple. The first thing you are going to do to this is to first re-express the denominator. The denominator will become what? S raised power of half. I told you that anytime you see square root, it's going to become power of half. So immediately you know that anytime you see bar 1 means minus. So this thing can become S raised power negative half. So that's the beginning. So this is the new expression you are going to work with. This expression is what you are going to work with. Anytime you have 1 over something, you can turn that 1 over to minus. So then you now proceed. But the first thing you are going to do is to bring down the minus as a coefficient. Let this minus half come to the front. So it will be minus half x. Then the next thing you do is to subtract 1 from the power. Just the way the power is negatively, leave it like that. Then minus 1 from it. Then when you do that, the minus 1 over 2 that you make the coefficient just now, just leave it. Then quickly go to your rough book and quickly find the LCM of this. If you do this very well, you are going to definitely have minus 2 all over 3. Because the LCM will be minus 1 over 2 minus 1. LCM will be 2. Alright, 2 times 2. 2 in 2, 1. 1 times 1 minus 1. 1 in 2, 2. 2 times minus 1 minus 2. By the time you say minus 1 minus 2, you are going to have minus 3. Sorry. If you do it very well, you are supposed to get minus 3 all over 2. So if you find the LCM very well, you are going to get minus 3 all over 2. So we are going to have minus half s raised power minus 3 all over 2. So you need to get the LCM of this expression before you can get this. Now when you now get here, the next thing is to leave this coefficient like this. Then x is here. Then I told you anytime you have minus as a power, it means everything you have with that minus come under it. So once you introduce your bar 1, the minus will disappear. So immediately you can answer minus 1 times 1, that will be minus 1 all over 2. And now you now have your x raised power 3 over 2. Now for you to express this answer finally, I told you that anytime you see a fractional power, so let me try to, I think this one is already getting low. Sorry, let me use the wider part. So you can just come here. So this is the minus half s raised to power of minus 3 all over 2. So the first thing you are going to do is to interpret the minus in the index so that everything that is with the minus can come down. Immediately you can, okay, there's minus here. Minus 1 times 1 will now be minus 1 all over 2x 3 all over 2. So for you to finish up, so the 2 is here. Anytime you have a fractional power, the denominator is the root. Please, not the numerator, denominator. So the denominator will go and root whatever you have. Then you will now be left with what you have. That's the answer. So the cube is still there because it's the numerator. Numerator does not turn to root. It is the denominator that turns to root. But what of if you now have s raised power 2 over 3? If it is 2 over 3, that means the root will be cube. It will now be cube root of x squared. But that's for another kind of question, right? You can pause the video and practice it as well. Now, let's take the final question for this class, right? What if you have something like this? If y equals to root n into x, find dy dx. So if you have root nx, find dy dx. Very simple. So the first thing you're going to do is to re-express what you have. So whenever you want to re-express, you know that I said the root is the denominator of a fraction. So immediately you know that for x to be standing alone here is having a 1. Yes, you have to put the 1 by yourself. So since 1 is already here, standby, that means this root n, is actually a denominator of the fraction before it now turns to root. I said anytime you have a fractional power, anytime you have a fraction as power, the denominator of that fraction is the root. So before this n jump here to become the root, this was where it was. So your own is to return this n back to where it was. All right. So there's no one in the question, but by yourself, you know that when a letter is not carrying anything, there's a 1. So let the 1 be the numerator and bring back the n to come under it. That's when you have re-expressed what you are giving. Then you cannot proceed. First principle cannot be done. You see, you cannot use first principle unless you express whatsoever you are giving in terms of power. So if it does not look like this, you cannot go on. So this format is not okay. That's why you need to interpret it to this form. So once you now have an index, then it now be easy for you to what to simplify. All right. Now let's proceed. So you have to bring 1 over n to this side. That will be 1 all over n x. You know you have to minus 1 from whatever you have. That means 1 over n minus 1. So you leave your 1 over n. So you go and do your SCM. So if you find SCM for this, you are going to have 1 over n minus 1 over 1. Then your LCM is n. N in n is 1. 1 times n is 1. Sorry, n in n is 1. 1 times 1 is 1. All right. Now, here now, 1 in n is n. N times 1 is what? Is n. So this is what you get when you do the SCM. You are going to get 1 minus n over n. 1 minus n over n. That means what you are going to get here now is what? 1 minus n over n. All right. So this is your final answer. But for you to finish up, just continue 1 over n. Let it be here. Then you know I said the denominator is the root. Then let your root go back again and be where it is. So you will leave the denominator. Then let the n go and root the x. Then that will be your final answer. You can pause the video, then drop your question in the comment section in the video. Then I'm going to respond to them one by one. Please kindly subscribe to my channel, share to your friends, and rewatch again so that you can understand this concept. Thank you very much. Once again, I'm Phillips.